Welcome to this explainer. Today, we're going to demystify the automated teller machine and reveal the absolutely incredible engineering hiding right behind that screen. We see them on literally every corner, right? But we rarely stop to appreciate the absolute marvel of technology that makes them actually work.
So what really happens when you punch in your PIN? Well, it feels super simple on our end. You put a card in, punch some numbers, and grab your cash. But the reality, when you press those keys, you are kicking off this wildly complex mechanical and global digital orchestration. You're activating a high-speed, secure network, some heavy-duty mechanical engineering, and incredible digital safeguards.
To wrap our heads around how this works, we're going to trace this journey through 5 quick steps: anatomy of a data terminal, Fort Knox in a box, the global digital journey, delivering the cash, and finally, the future of ATM security. Okay, Section 1, Anatomy of a Data Terminal and the User Interface. First things first, we have to stop thinking of the ATM as just a fancy cash box. At its core, an ATM works as a highly sophisticated data terminal. So you are interacting with 2 specific input devices to securely identify yourself. That's the card reader, which grabs your account info, and the keypad for your PIN. On the flip side, the machine has 4 output devices to actually complete your transaction. It guides you using the speaker and the display screen, logs everything with the receipt printer, and then, of course, there's the cash dispenser.
Now, acting as the absolute brains of this whole operation is the main board. All those inputs and outputs plug directly into this motherboard, so it acts as the ultimate gatekeeper between the public street and your actual bank account. And because these machines are out on the wild, totally exposed to the rain and elements, the main board has to be meticulously grounded. Literally, if a little moisture gets in and the board shorts out, the entire system goes down.
Moving on to Section 2, Fort Knox in a box, the physical fortress. Let's talk about the sheer physical security required to house up to $150,000 in cash on a public sidewalk.
Check out this number, 400. What's really fascinating here is that this represents the total number of working parts functioning in unison inside a single ATM. You've got smart card readers, secure vaults, high-friction rollers, and precision sensors all packed into this incredibly tight space.
And to protect those 400 delicate parts, the ATM is encased in a massive 220-kilogram solid steel box. The walls of this safe are 1.3 centimeters thick and forged together with super strong welds. This basically ensures that the cash inside stays perfectly safe and ready to flow, no matter what kind of physical battering the outside of the machine might take.
This means potential criminals are facing a literal Mission Impossible scenario just to get past that outer door. The door has this super wide bolt running along its edge, and the only way in is through a keypad boasting a 1 in a million combination. Once the right code is entered, it rotates to release a deadbolt, which allows the handle to swing an aluminum pendulum and finally pull back that massive bolt. All right, Section 3, the global digital journey and routing the data. Let's move away from the physical mechanics for a second and zoom out to the invisible digital ecosystem that spans the globe. When you insert your card, the machine has to instantly connect to your bank server to verify your PIN and your account balance before it ever authorizes a cash withdrawal. Whether it connects through a modern high-speed VPN, a dial-up modem, or even a wireless cellular device on top, it speaks a very specific language called ISO 8583. This is the International Standard Protocol framework for exchanging financial messages. This digital conversation happens in very specific message blocks. Take the X1XX message series, for instance. This is a fast-paced authorization request sent from the terminal to the issuing bank. Think of it as the, "Hey, can I have this money?" message. It carries your encrypted PIN and the withdrawal amount across the network to double-check that you are who you say you are and that you actually have the funds available.
Right after that initial authorization, the X2X capture message kicks in. While the first message just checked your balance, this second message executes the actual movement founds. It ensures accurate financial processing by officially debiting your account before the network sends the final yes back to the ATM.
Which brings us to Section 4, delivering the cash with high-speed precision. Once the network says yes, we zoom back down into the high-friction mechanics of the machine to actually hand you your money. The machine basically acts as a robotic teller, churning through precise steps to spit out up to 5 notes every single second without ever jamming. Deep inside that steel safe, a serrated rubber roller kicks up just one single note from the cassette, hands it off to a smooth conveyor belt, and passes it through an incredibly sensitive optical sensor.
And that optical sensor is absolutely crucial. As they say in the banking world, our customers wouldn't be real happy about giving somebody $40 instead of $20. The sensor is strictly trained to measure the unique thickness of different currencies, so notes never double up. Since different countries have different sized bills, the machine learns the exact dimensions of the cash it's dispensing. If two bills stick together, the sensor detects the extra thickness instantly and dumps them right into a reject bin.
Section 5. The future of ATM security and stopping skimmers. Because despite the heavy steel and complex networks, the biggest threat today is actually digital skimming.
This is why ATMs have to constantly evolve, and we're seeing a massive shift away from easily copied magnetic stripes. Those old stripes hold static, unencrypted data, making them a prime target for hidden skimmers. Instead, we're moving toward much more secure EMV chips and tap-to-pay NFC tech. An EMV chip creates a completely unique encrypted transaction code for every single use, so even if a skimmer grabs it, the data is completely useless for future transactions.
Modern anti-skimming tech uses a layered approach. It integrates things like Parabit MMR 2.0 readers, which immediately encrypt your data the millisecond you insert your card. On top of that, the ATM runs continual scanning software to detect foreign devices. If it senses a skimmer, it can literally shut down the machine remotely. And honestly, we're even moving toward cardless authentication with mobile wallets to just bypass the card slot entirely.
So, as we move closer and closer to a cashless society, you really have to wonder, will the ATM survive or simply evolve? It's clearly transformed from a simple cash dispenser into a highly secure global data terminal. But what role is it going to play for the next generation of consumers? As digital wallets become the norm, the ATM is already evolving to meet us there, proving that the incredible engineering behind the screen is far from obsolete. Thanks for joining this explainer, and remember to keep questioning how the everyday world around you actually works.